this all these treatments as a very new type, or it should not appear to you complicated. That was the whole reason behind it. And then the second thing is, you know that in numerical methods we discussed about the eigenvalue problem or the free vibration problem. So that should everywhere be there as a prerequisite. That means if we try to study the dynamic behavior of multi-degree of freedom system or a two-degree of freedom system or even a single degree of freedom system, first we should understand the behavior under free vibration, because that gives us or that helps us to identify the dynamic characteristics of the system. What are these dynamic characteristics? These are natural frequencies, natural periods, and mode shapes. Frequency can be converted to mode shape. All of you know about it. Well, before since we are studying multi-degree of freedom system, we should first know what is really meant by degrees of so freedom is the minimum number of displacement components, as we discussed last time, at least required to be specified to completely describe the deformed shape of the structure. But when we tell this, then there are many things involved. I mean, sometimes the same structure, for the same structure, we may consider different degrees of freedom. Why? Because often there can be some approximation. If there are many degrees of freedom, and then that may be approximated as even as a single degree of freedom, or only that may be considered consisting of few degrees of freedom. The objective of doing that is to pick up the dominant degrees of freedom in which the maximum deformation is taking place, and or other way speaking, that due to the maximum deformation in those degrees of freedom, the maximum strain energy is generated. There are some other degrees of freedom where some small deformations are taking place, and because of that, the strain energy, if the total strain energy is 100%, maybe only they are contributing, say, 5 to 10%. Therefore, instead, maybe in a third freedom system, just to understand the preliminary dynamic behavior or the predominant dynamic behavior, we may pick up even 5 or 10 degrees of freedom, and that may give us kind of a sufficient idea about the dynamic characteristics of the system. I'm just trying to explain this issue with these figures. You see that this is the 3-story frame. This we considered even in the numerical methods class when we talked about the free vibration. The story level stiffnesses are given, and the story level masses are also given. Now, if you see that for earthquake, this structure is subjected to only lateral forces. So here, consideration of 3 degrees of freedom are sufficient. But the same frame, you consider that when it is subjected to dead load or live load, that means under gravity loading, there can be a rotation, there can be symmetric rotation at the two ends. So these rotations are also needed to be considered, but there is no lateral force, therefore there is no possibility of sway. So for this particular set of structural geometry and loading, if we consider these 6 degrees of freedom, then it will be okay. So you see that the same system, depending on the nature of the loading and the nature of the structure, we may choose different number of degrees of freedom. Can anybody tell me that what you see in a general type of loading? I may say, if I say that, well, there can be load from anywhere, maybe dead load, live load, maybe lateral load, I mean, any possible kind of loading. So what will be the degrees of freedom? I mean, and if I want to be very accurate, then what will be the total number of degrees of freedom of this structure? Can describe the deformation of such a structure, then truly speak for any general type of loading, then truly speaking that at each joint there can be 3 degrees of freedom if it is a structure in plane, that means in a 2-dimensional plane. It is not a kind of a 3-dimensional structure, then it would have been more. But in here, you see that at each joint there can be a movement in x direction, in horizontal direction, in vertical direction, and there can be rotation. So for 6 joints we have 6 into 3, total 18 degrees of freedom, which can take care of any general type of loading. For example, if you with this type of loading, if you mix up this loading, this lateral loading too, then there will be sway in all degrees of freedom. And then also we are not taking everything together, but still the degrees of freedom is having 9. Okay, then that means what we are neglecting, if there is a translation here along y direction and in x direction, then what is happening is that is going to create axial force in the member. That means, say, if there is a horizontal movement of this joint and there is a horizontal movement of this joint, if these two movements are not same, then what will happen? Either this member will undergo compression or the member will undergo tension. That means some axial force will develop. Now, in most of the cases, we consider that the frame members are axially rigid. The reason is that, if the axial force is P, then the total strain energy stored is P square L by 2A. All of you know this kind of formula. So when the total strain energy is considered, then it has been found that the contribution of the strain energy due to axial deformation is very less, say about 5%. So in most of the cases, to avoid complication, and we are satisfied with 95% error, because 95% of correct result, because this is for civil engineering structure. I do not tell that for a missile structure you can afford this. No, you can't afford this. So it will vary from situation to situation, and that is why. But for civil engineering structure is a very large gross structure with a very high stiffness, and therefore and the deformation comparatively is very small. But say if you see the wing of an aircraft, then you will find that the wind is slightly moving up and down when it is flying. If you really curious about it, you will see many things, many activities are going on in the wings. So the situation there, one has to be very accurate, very accurate, because the first thing is that it's really directly connected with the life of the people. And secondly, if it is not accurate, then it will not work. But say for these structures, I can afford to have 5% error or even 10% error, because there are factor of safety involved in the design processes, and we know that it will take care of that. Therefore, so most of the time, we try to neglect the axial forces and we try to proceed. So you see that in here the axial forces are neglected, and then and then in this particular case, the axial force of course are neglected, and then also the contribution of bending of the beam, that is neglected. It is considered that the beams are infinitely rigid and all the masses are lumped at the level of the beams, and these columns only contributors which are given for the first story, second story and third story. So this is the story about the nice insight into the behavior of the structure, so that you can suitably choose the degrees of freedom. I mean, of course, it is the minimum number of displacement components, but even if say still it becomes say in the order of 1,000, then to work with that or to derive some initial idea about the behavior of the structure, you have to be choosy. You have to pick up some degrees of freedom which are predominant under that kind of loading and for that particular structure. Therefore, there you will require your insight, which computer cannot give you or any package cannot give you, and you have to choose those degrees of freedom, and so that you can interpret the result properly. For example, if I am interested that how much rotation is being created, how much bending effect is being created, say for the second case, then obviously I should consider these columns or these beams are actually rigid, because I'm just trying to isolate the effect of being to understand. Most of the cases, the bending deformation really contribute to the 90 to 95% of the strain energy, and the rest is contributed by the strain energy in axial behavior as well as the strain energy in shear deformation. So even the addition of these two are very, very less, so that we can neglect them. So this is the story of freedom. That yes, it is minimum numbers, but still on that we can apply our insight, whether a larger number is to still be considered or a lower number will be considered, depending on the fact that what kind of behavior we are trying to capture. That means a structure can have different degrees of freedom. One may analyze with different degrees of freedom depending on the nature of the loading or depending on the nature of the deformation he wants to study and for which he is designing. In most of the cases, consideration of the bending deformation becomes sufficient. And for this kind of a model, this is called shear building model. Why shear building model? Basically, if you consider that this beam is a cantilever beam, then it is behaving like a shear beam. That means the way the shear deformation takes place in the beam, there all the cross section remains parallel to each other. For bending deformation, the cross section rotates. Now in here, when you are having infinitely rigid beams and you are pushing, then all these levels, they are, and if you consider that as if it is a cantilever beam, so all these levels are, there is no rotation, so all these levels are remaining parallel to each other. And so from that, the name comes as shear building model. Okay.